Hey everyone. I'm just gonna wait here a minute. Confirm that I can hear myself. And I see that YouTube is putting my logo over my face. How do I remove that? I confirmed I can hear myself. I don't need the headphones anymore. Bum ba-dum bum. So I think we do this in channel settings. I'm sure this is very exciting. My channel, customize, let's remove. We'll get there. In fact, you know what's going to be a lot easier? We're going to just hide you and move me over here. Perfect. Okay. So let's see, where are we? So I did a couple of things up front. So today we're going to use this tool I've been working on called Get Series to analyze the commit history of a couple of open source projects. Today we are going to take a look at SwarmKit, Moby, and Kubernetes. Now, because some of these repositories are slightly large, I thought I would just run Get Series up front so that it was not something that we had to sit and wait on. Although we are still going to do the import live, which I'm hoping won't be too bad. Now, just so that everyone knows how long this took. The SwarmKit was the smallest. That took 50 seconds to run Get Series. We can see the command here. So it's just Get Series analyze, and all I'm going to do is just output or redirect all that output into a file. If I do that without, then you'll see what actually gets emitted by Get Series. And this is InfluxDB line protocol. We can just see measurements at the start. There's some tag information, context that we're applying to the time series. And then we have some field values on the end. And we'll dig into this as we get into the dashboarding and graphing segments. Moby itself took nearly 3 minutes, so a little bit larger than SwarmKit, but not too bad actually. I believe Moby has around 40,000 commits, and we managed to process all of that, including every delta in the Git repository, in under 3 minutes. Now, Kubernetes was obviously the one I had a little bit of concern over. Now, it doesn't have that many commits either. There are 90,000, give or take, I believe. But it did take substantially longer. So it took 13 minutes and 9 seconds to generate the line protocol for the Kubernetes repository. And I think the reason for that is probably just a lot of larger commits. We'll see that in the graphs as well. It's hard to tell. We'll know when I get to the graphs. So what I want to do next is import all of this into InfluxDB. So what I've done locally is I have compiled InfluxDB on the master branch because just last week there were a lot of performance improvements, particularly around Flux, that will hopefully make our queries across larger timeframes faster, so we're not watching it spin for too long. And of course, because I'm compiling against master, I do have a little bit of concerns that I may break InfluxDB. So I have a backup plan if that happens. I do have a make file here with a couple of just common steps. So if we need to, we are going to run the latest beta, the beta release Docker image or container image, which hopefully is a little bit more stable than compiling off the master branch. We have a setup command here, which just allows me to kind of, set the token that I want to use up front rather than having to go into the UI and copy and paste that around, which means that hopefully I won't have to modify this telegraph config. This telegraph config is just going to scan for all the line protocol files inside this directory, which there are none yet, but we're going to add them in. It's just saying, look, this is line protocol at influx format, and we're going to throw that into our InfluxDB locally. So that's my next step. Let's get this data loaded. I will start with SwarmKit. It should be nice and fast. We will then pull in Moby, and then we will maybe just leave Kubernetes running as we start to look at the Moby and SwarmKit graphs. But we'll see. Now, the biggest time sink when we import the line protocol really just comes down to how many entries we need to write to the server. Right now I've not checked, so we're going to do that first. So I'm just working out of a temporary directory just now. What I want to do is copy my line protocol files. So we're going to grab Docker, that's GitLab, Docker, SwarmKit, and SwarmLP. We'll stick that here. Next, we're going to grab Moby, Moby LP, and lastly, we will grab Kubernetes. If anyone does have questions along the way, I do have the chat open, so drop them in. I think there's around a 40-second delay, so just be patient with me if I don't see it right away. Whoa. My temporary disk. There's a problem I didn't think I'd hit right away. Okay, let's untemp this. So let's just jump into GitLab and we'll make a git lost directory. And I'm going to move everything from this temp. That's home. So I like to work out of a temp directory pretty much all the time. I don't know why. Because I have a few Z shell plugins, and those plugins give me per directory history. So when I do things like this, and I don't really necessarily want that history jumping around or just filling up a folder, I always tend to jump into temp. It's just habit. Okay, so let's close code, spin that back up, and we were copying. Let me just mute myself because I can actually hear myself come through that. We were copying the Kubernetes line protocol. Nice. Okay. So I still need my local InfluxDB directory because that's where I'm going to run it from. The copy is not fast. Oh, I do realize that my face is now covering up all the commands. Let's shimmy that over. Boom, boom, boom. I'll just keep moving him around. This doesn't need to look professional. Okay. Well, 30 seconds to copy that line protocol. All right, so we have 13 gig. Ouch. Okay, so SwarmKit, we have, what is that? 2.3 million lines of line protocol. Moby, we are sitting at 8 million lines. And the scary one, ooh. Damn. 43 million lines of line protocol. Whew. Risky. Right. What we're going to do is run influxd. Now, let's just browse to this. Oh. I will need to tell it the assets directory. Maybe I'll just run it through Podman. Let's see if I can remember how to do this. UI assets. All right, we're jumping into the backup plan already. InfluxDB with Podman. Okay. There we go. All right, so what we're going to see here is the getting started screen wants us to create a user. Authentication cannot be disabled with InfluxDB2. Now, I do not want to set that up there because I want to specify my own token, so I don't need to change my Telegraph config. So what that means is if I jump over here and just hit refresh on this, then I should be able to log in with user and password 123. And this is the clean slate. We have no data, no dashboards. It's just some internal stuff here. We do have a bucket that is created in the setup command. Let's get some data first. So we are going to pop open this Telegraph config. We are going to grab Moby and SwarmKit into the line protocol directory. And I'm going to run Telegraph config telegraph.conf. We want to run that with debug. Okay, just kill it. So that we know when it's finished. So it's going to give me information on, well, first of all, which files we're importing. Good, it's just Moby and SwarmKit. We can see the buffer filling up as they're starting to process those files. I have a very short flush interval on this. Hopefully just keep it fast. And what we want to kind of see now is just, hopefully the buffer will stop filling and start actually emptying. But we know we have a substantial set of metrics here. So let's leave that running for just now. What we do want to do is import some dashboards. Now, I've tried to make this as easy for other people to use as well. So on GitLab, raw code / git series example, I have packaged up the dashboards that we're going to be using today. InfluxDB 2 ships with a component called Packager, which allows us to import these dashboards in a very declarative and Kubernetes fashion. In fact, you'll actually see that the spec for the manifest is very much inspired by Kubernetes. I have copied this file here. So now I want to import it. And we did this with influx package file, packager.yaml. I will just point it to the host. I believe this is the default, but never hurts to be explicit. And we're going to say, yes, create those resources, and hopefully we have 4 dashboards available. Now if I click on this, it should just break, or at least we're not going to see any data just yet. Especially because we have it set on 1 hour. Now, the first commit on Docker would have been what? Sometime in 2013, 2014. So let's just... We have some data. So we'll zoom out first. We don't want to dive into, obviously, looking at this on a daily basis over a span of 7.5 years. Maybe not going to be entirely useful at the start. And this is still loading data. We've currently processed 20,000 commits, so we've still got a little way to go. So let me explain the setup. So we set the time period here. I went back as far as I feel I need to, which is roughly correct. The first commit was April 2013. We have a couple of variables that are configured for us inside of the packager template. So we have this repository one, which actually executes a Flux query on our Git series bucket and just pulls out all of the unique repository tag values so that we can dig into individual repositories without having to hard code anything. We also have that window filter. So by default, InfluxDB tries to calculate the window that makes the most sense based on the density of the data within the time range that you specified on the dashboard. Now, while I trust InfluxDB with that, I want to get very specific in the way that I'm going to query this data. So I'm actually just going to specify a variable called my window period, where I can break things down to dailies, monthlies, quarterlies, weeklies, and yearlies. And we'll kind of play with them as we dig through the dashboards. So if we come back to the overview dashboard, we're now at 42,000 commits. I think we're a good chunk of the way through there. We'll take a look at just one of these queries to see how we consume those variables. Now, because variables in InfluxDB2 can only be strings, one of the things I do need to do when I consume this is actually cast that string to a duration literal. So you can just see my aggregate window, cast into a duration, and performing an arbitrary count of the commits over time. Let's pop over and see where we are. We are complete. So buffer fullness is 0. We imported all of those. I didn't actually see when it finished, but if we scroll up, 47, in fact, okay, so it just finished. So it did take around 300 seconds. 4 minutes and 6 seconds. Perfect. Now I have a dilemma. Now, do I want to risk importing all of that Kubernetes data while exploring the Docker stuff? Or do we do a little bit of exploration on the Docker stuff before I kill InfluxDB? Let's take a look at Docker first. We'll at least take a look at the overview dashboard. We'll maybe take a look at one of the breakdowns first, and then I'll maybe hopefully feel a bit braver about doing the Kubernetes import. So let's refresh this one more time. We have all the commits. We're breaking down by quarter. And what we can see here is the first couple of graphs that we provide are just a kind of a way to understand the commit history. Now, we can see that in the early days, there's a lot of growth in the Moby Docker project. But actually, it's the number of commits is on the decline ever since 2017. I'm not sure why that is just yet. I'm trying to think of major events that have happened over the last 3 years. Obviously, Docker, as a company, has always failed to find kind of the path to profitability. Other container technologies have popped up. I'm using Podman locally. It could just be that they broke out a lot of their primary repository into other repositories. I know they went heavy down the kit route where they had, Linux kit, they had VM kit. I don't even know the names of all the kits, network kit, swarm kit. So it could just be a lot of that code and a lot of the effort from the community and by the company has been pushed out other avenues. Or it could just be that the company has maybe been shrinking in size, but I don't really know if that's the case. Hopefully we can build slightly stronger inferences as we look at more data. So, all right, so this is the breakdown across multiple repositories. So obviously there was only one repository until, what's this? First quarter 2016, when SwarmKit was a thing. So quite a lot here. In fact, that's an awful lot of commits in the first 6 months. That could show just that maybe some of the code was extracted from the primary repository, although I don't think Swarm was ever baked into the Docker CLI. I think it always was slightly separate. Let's try and maybe come back and work out what that is later as well. A little spike in commits here. What's that? October 2019. Again, right now, I'm not really sure what that spike could be. But this is an InfluxDB, so let's change this window and see if it maybe gives us maybe a little bit more information into what's actually happening. So if we break this down by month, it should, so it's not as smooth anymore because we're not aggregating as much. So, I mean, this spike still exists definitely around October 2019. I'm not sure what that is. So definitely sharp decline here. I'll maybe need to do a little Google and just check what happened to Docker at the end of 2016. I'm not even sure when they raised money. Normally, when I analyze open source projects that have raised money, You can generally tell where that raise was. So, in fact, why don't we try and guess that now? So, I'm assuming the first raise has to be just this crazy spike. Yeah, so let's go with April 2013. There is growth here. I'm not sure if it's funding, just because I would maybe expect to see a slightly steeper curve. But it could be maybe when the project was open sourced, and I'm not sure what date that was, but we can always look that up too. I would say this is definite funding, probably March 2015. And you can just see here, as the company was really focused on Swarm, that there's a massive dip in the effort to the contributions to Moby or Docker itself. But that does come back up. So I'm going to say maybe there was funding April 2013 and 2015 in March. So we'll go Crunchbase Docker. Show me the money. Okay. Pre-seed, angel, blah, blah, blah. So January 2014 and September 2014. So this was a raise, but the peak of that curve is actually a little bit later than I thought it would be. A little bit earlier than I thought it would be. But I guess then we also have a little follow-up peak here. So definitely the round was there. In fact, am I looking at the wrong dates? Yeah, that's the wrong dates. Oh wait, I'm getting everything wrong. Okay, so we don't have data from here, so let's ignore that. January 14 and September 14. All right, so there is a spike here, and then there was a raise here. Okay, so that's more in line what I would expect. If the raise was here, especially just with that being the Christmas or holiday period, there would be a sharp decline, and then as January is, or as we're pushing towards the first quarter of that month, there's been a substantial increase in contributions. April and November 15. Yeah, so but yeah, I mean some of these spikes do definitely line up. But that's not that interesting. That was just a curiosity of anything. So now let's take a look at contributions. So definitely a decline ever since 2017. I'm not sure how to explain that. Total contributors over the years, 2,500. Let's break that down. SwarmKit, very little traction. I don't think that's a surprise. Especially, I'm assuming when we pull in the Kubernetes data here, we're going to see that pretty much make this line indistinguishable. It's just going to be flattened right down here because I'm assuming the Kubernetes one is going to be much larger. But there has been growth, a lot of growth contributor-wise to the Docker Moby project. But something definitely happened in 2017. I'm not sure what that might be. Maybe prod some people and see what we can find out. So we're taking a look at commits and we're taking a look at contributors. This is now the release information. So what we can actually see here is I don't think SwarmKit has really ever had a tag on its repository. One tag in 2016. But we do see there's a pretty sporadic but cadence that does exist with Docker itself. Definitely, these kind of inclines early on just show that the project was young. They were tagging releases quite often, pushing them out maybe to get some feedback. Definitely a quiet period here. But just, random peaks as we go. And these graphs are the same. These are just two different ways to kind of visualize it. With the scatter here, we can see that volatility early on again. Just when these dots are further away, it just means there's not a lot of consistency. There is consistency here, but still, flurry of activity outside the norm. And then when you view that as a histogram, you can see there's not a lot of level across here. Extremely volatile here, a little bit here. Not sure what the deal was there. Maybe slightly more consistent towards the end. Something else Git series gives us the ability to do is just to understand the files in the repository. Now, because Docker is pretty much entirely written in Go. All we're just going to see is one big purple line of Go. We also have the markdown line here. So what's that? No documentation that existed in this project, at least very little documentation existed in this project until the middle to end of 2014. And I mean, that's a little bit worrying, but there's not been very much documentation or markdown files added to the repository. That could just show that the docs were extracted to their own repository at the early 2018, late 2017. I'm not sure. We've got some PNGs being added and some random crappy files that someone probably didn't mean to commit. Okay, what have we got down here? We're just breaking down those file types again by repository. Most of the documentation is in the Moby project. Go for Swarm. I don't really see a line for Markdown on Swarm. Concerning. Okay, something else that Git series gives us the ability to do is try and get help. Maybe not so much for an open source project, I guess. But if you're working, I mean, if you were going to use these, if you were going to use Git series and these dashboards in your private company or organization, it could be a good way just to say, how do I get help writing Markdown? You know, I put Rust here just because Rust is obviously the new shiny that a lot of people are adopting. But if I want to know who the main contributors to the documentation, and I'm guessing that the documentation is the Markdown files, then Mary@docker.com. I'm assuming they have 1,200 commits of Markdown now. If I want to understand how to write Go code in this project, we've got 7,000 commits from github.gone.nl, and in fact, those top 5 there are probably the people that I'd want to go speak to understand the Go code here. And what I like doing with this table here is it also just shows you some of the random crap that's in the repository. So who committed to .1? Well, quite a lot of people. I'm going to assume that's not an accident then. .bsd, .debians, .fedoras, who's committing the images. Oh, there's a nice Mac OS folder. That's always a pleasure to see. Do we have a DS store? No DS store. AI file, nice. Oh, there's something from Sublime or TextMate, depending on when this was. Lots of random stuff. I don't think there's anything else particularly interesting. Oh, a bit of Perl, nice. If you want help with Perl, that's the person we're going to go chat to. Okay, so let's take a look at our next dashboard of this. This is the single repository, kind of a deeper dive. So hopefully we can find some patterns and a single repository here. Now I am running this over a large window. I'm hoping it's not going to take too long. Okay, so this is the repository query that we showed at the start. We're going to take a look at Moby. I'm assuming that's going to be slightly more interesting than SwarmKit, and we'll just stick with the period of a month for the time being. Now, what this first graph does is it's still breaking down the commits, only this time we're looking at the stats on each commit itself. So we want to understand how many insertions there were, how many deletions, and how many files were modified as part of that commit. Now the files modified should always be dwarfed by the insertions and deletions here, but because generally we write a lot more code than we do spinning up new files or touching files, etc. What the blue line above the purple line means is that we're generally writing new code. Purple line being bigger than the blue generally means that we're deleting code. And what you would expect to see is generally these lines will run very close to each other. The LP extension is just line protocol. I made it up for the question on YouTube. I made it up for the purpose of this. It's just a text file in line protocol format. So what I would normally expect to see in a stable repository those lines are tracking each other pretty frequently. If there are any major deletions, they come generally after a major insertion to just kind of show refactoring or extracting of code and kind of cleaning it up. When the lines are running very, very close together, it just means that only changes are being made. I generally consider that a little bit of a warning sign, because if you're always just changing code, you're not really driving any new features, probably just fixing a lot of bugs. And if we see too much blue over the purple, it means that we're only writing new code. And that's something I would expect to see early in a project, but not necessarily later. But of course, it depends on the way the team works, the way that they handle new features, etc. So now, we know there was money raised here. That would show this explosion of new code. I guess new developers coming onto the team. They're all working on new features. We see that again here. I can't remember when the funding was, but you know, they are definitely focusing on new features for the first 12 months. And again, that's totally normal. You know, major feature expansion here. Then we've got a period of kind of fixes, another little bit of feature expansion here, but then a heavy feature expansion here. A little bit of cleanup, and then we're back to that kind of modifying code rather than investing in new code. This is probably a little bit of refactoring here. And then this is what I mean here. I keep saying here. These bumps are generally, I like to see these when I'm analyzing the Git history of a project. You know, massive amount of new code to me would show we're rewriting this different component, and then when we come back and we remove something else from the project. So it could be, right, we just want to extract this out of this directory where it's maybe coupled with a whole bunch of other components, and we want to extract it over here. There are graphs further down the page where hopefully we can actually identify what that refactoring was. So we'll try and come back to that. We've got a lot of new development here, followed again by this deletion. This is good. Again, I think it's just refactor. And of course, that's usually healthy after there has been this kind of feature explosion here. Not an explosion, but it's still, there's a bit of prominence there with the amount of insertions in the code over deletions. Now these, I haven't worked out what these double peaks really are yet. I mean, it's an awful lot of deletions, an awful lot of insertions. It's just one big massive change to the code base. Again, let's try and make sure we come back to what is this? The start of 2017 and this 2015 July-ish. And we'll see if we can actually, when we do the breakdown of the directories that the code changed in, try and work out what happened here. Okay, so moving on to later times, we don't need to go over all this again. We see feature-driven development, feature-driven development, feature-driven development, feature-driven development, with little flurries of changes and bug fixes along the way. Thanks, John, for answering that. Okay, so total commits, mean commit per window, not very useful, right? Because we've already covered that in the overview, we don't need to go over that again. The next bit of this dashboard tries to give you a sense of what a standard commit looks like in this repository. So we break it down by quantiles. We have the 90th quantile, the 50th quantile, and the first quantile. So you should rarely have a commit this size, rarely have a commit this size. Most of your commits should be in this ballpark, leading up to this one, but hopefully not too close. So the average commit across the Moby project, and again, we're looking at a very large time period right now. So the stats are going to be somewhat skewed. If we break this down to 3 months, which I'll do, say 5 minutes, we'll see an actual true representation of what a standard commit looks like now. And we could probably run that against the first 12 months. And I would actually expect those numbers to be substantially different. Lame protocol. Yeah, sorry about the accent. I'll work on it. Okay, so standard commit across the lifetime of this project is you modify one file, delete 4 lines, and insert 11. Pushing up towards 142 insertions, 70 deletions, and modifying 8 files. In fact, you know what? Let's just break this down now. What does it look like in 2020? If I was coming to this project now, we can see that the standard commit, you would modify 2 files, 4 deletions, 6 insertions, and while the 90th percentile is huge. So, I mean, probably been some chunky commits or refactoring in the last 6 months. I'm not sure if maybe that has something to do with the sale to Migrantes. Maybe they were starting to extract a lot of code out of Moby. I don't know, maybe I would see that more in SwarmKit. I don't know. Let's compare that to the feature days, 2015. So we just wanted to break that down to that year. Okay. The consistency across the years probably quite telling, and quite a mature development team. You know, this kind of commit mean, if you will, of modifying 1 or 2 files and, you know, making anywhere from 5 to 20 changes. To me, just shows that's a good indicator. I don't like to see that number get too high, that's for sure. Okay. Let's jump back over to our massive view of the world. Just give that a second. And we'll scroll down. So there's this release cadence. We've seen that in the overview. We're not going to look at it here. We have a table that's just going to show us all of those releases. So what we can see here is just the pattern, the name for releasing. You know, was that always the case? Oh, come on. No, they used to do semantic versioning. And that changed in 2017. So the current version is 1903. In fact, there's not been a release since November. Make of that what you will. Okay, so what about the offers as they have come and go over time? So we can see some crazy peaks at the start. So there's Solomon, who I believe was one of the founders. He was the CTO at the start, who committed a lot of codes in the early days and stopped writing code in 2015. I'm assuming, as a CTO, focusing more on growing the company, the vision, leadership, management, and all of those things. So obviously, his priorities were just changing around that time. But what we do see here, a lot of activity for a very short period of time. So maybe an early employee of .cloud, moved on in 2014, hasn't committed since. We've got Victor here. Interesting. So, you know, definitely a prominent developer from 2013 to 2015. I guess maybe, and so many random hypotheses just coming out now, but maybe took a leadership or management position in 2015. I mean, as an early developer on the product, of course, as the company grows, he's going to be, you know, maybe pushed into a position of leadership and management. Maybe didn't like it, lasted a couple of years, went back to being a developer, maybe moved on from the company in 2018. Complete speculation. But we can see that, you know, very prominent early on, dip in the middle, spike. Not sure what that was, but again, it's around that 2017 period where we did see some weirdness on the commit total graph, so I'm not sure what happened there. We can also see we've got more people. Let's see, is there anyone? Michael Crosby, still definitely one of the early employees, still at the company today. You know, nice kind of dip for a few years and then a little spike at the end. Not sure what that means. Who else have we got? We've got Jesse Frizzell, Alexander, David Calavera. Not sure why I know that name. Rings a bell. Prominent committer for a year. There's probably the person, I mean, highly speculative based on their commit history, but maybe the project lead since 2016, just with the amount of commits that are. Maybe the lead wouldn't be committing as much as that, but definitely someone who's driving the Moby project forward. And then we've got other people. So, and there's a lot of density around the bottom, and that's a good sign for an open source project. It just means we've got a lot of people that are getting in, you know, commits in their spare time, that maybe it's not their full-time job, or just, you know, trying to contribute to the project as much as possible. And these numbers on the y-axis are quite large. So this, these people are getting hundreds of commits. That's a lot of commits on a monthly basis. Even down to here where we're at the 30 and 40, these are still substantial committers to the project. Just kind of dwarfed by some of the more prominent people on the project. Okay. This big blue line is always my favorite. So what do we see here? Well, what I've tried to do with Git series is actually process all of the commit messages. And what I'm looking for is something that represents a semantic or conventional commit. So if you're not familiar with that, it's a specification that says, if you write your commits in this format, you're going to be able to deliver some intent or meaning behind your commit, because we're all, okay, I can only speak for myself. As a developer, it's very easy for me just to say fix, change stuff, new feature, whatever. And that doesn't mean a lot, especially to a computer, but even to other developers, sometimes we're lacking a lot of context into why we're actually doing something. So this is a specification where we prefix all of our commits with fix, feat, chore, refactor, test. We then give it a scope, which part of the component, which part of the project or the components was I modifying, and then a description of that change. So just by having this format to adopt, it generally makes me at least put in better messages. But because, at least the Docker project has never adopted this as a standard, which is what we see with these big massive blue lines. So what I'm going to do is just zoom in like this. And we can see some people are doing it. So we've got managed to pick up a type of Windows. So there's a lot of prefix on commit messages with Windows : by the looks of it. The daemon has been tagged as a type, so we're not really getting the information I would like to see here from this, which means I'm not going to get the same information that I want in this next bit either, which is where we try and work out which component they're actually modifying. But I do have a backup plan, so don't worry about that. Okay, so when we ignore the nones, again, we're just not getting any data here because that format was never adopted by the project. Now, because we're making good progress with this dashboard, I'm going to risk it and pull in Kubernetes now. So let's just drop that in. We'll pull out Moby. We don't need it to reprocess that. And we'll fire up Telegraph again. Okay, it's running. So we do have a plan for getting past the components and the conventional commits. So where are my dashboards? Okay, so we'll come back to these table helpers in a minute. What I'm more interested in right now is a directory breakdown. So although the commit messages themselves cannot be processed, I still can work out which directories the commits are modifying. Maybe I was a bit quick to start running this Kubernetes thing because my dashboards are going a little bit slow. We'll give this a few seconds. I may either narrow the window or pause the Telegraph import. I'm not sure yet. Decisions. Oh. Alright, let's see. What are we doing buffer fullness wise here? So 193. So the buffer's still going up. We're still processing that line protocol. We are writing a substantial amount of metrics, but the fact that the buffer is going up means I'm not really past the worst of it. So decision, make a decision. And I've definitely broken that window now. Right, let's narrow this down just for a few minutes. See if we can get enough data to start looking at those directory breakdowns before I make a decision to stop the Kubernetes import. So I'm hoping that just by dropping this time period down to the last kind of 18 months, the dashboards at the bottom will load, and then we'll come back and do the 7.5 year analysis. So let's go. Where is directories? There we go. So let's try giving it a few seconds again. Also, it doesn't help that I have quite a lot of graphs on this board that are all fetching, a sizable amount of data. It made sense to maybe break this up for larger repositories. And we can see that this number is still climbing. It's a big commit, a big history. I got too confident. Number's still going up. How big was it? It was 40 million. Mental note to self, use a cloud VM next time instead of my laptop. So 5,800, 5 million, 6 million in the queue, 40 million total. I kind of think to just, yeah, let's let it run. And I have some graphs now, so at least I can talk about something instead of mumbling to myself. Okay, so this is the 18-month. We'll come back to the 7-year, but this, when a project doesn't or didn't implement conventional commits very early, it can be difficult to understand what was actually being worked on. So another thing that Git series does is it puts enough tagging on the commits that it stores in influx that we can see just what directories the changes were happening in. So what we see here are some spikes. So this is just test data. Oh, now we've got Kubernetes in here. Oh wait, that's probably why that was so slow. All right, let's jump back to Moby. Oh, my pure computer. Come on, ThinkPad, you got this. Maybe. Mm, 7 million there. Oh, we got some dodgy commits that can't be parsed. Yeah, I don't think I've got enough escaping on some of the actual when we process the line of code that changed within the deltas, there are some things that I don't think I'm checking for and escaping for. So I need to go back and deal with that. But okay, this is Docker, right? So 18 months of the Moby project. So we can see a lot of work happened on the integration CLI here. No idea what that is. Project commits their vendor directory. That's going to make analysis a bit of a pain in the ass, to be honest. We can see, Go projects love to keep as much code as possible in the root directory. So generally, seeing a dot here, we just get kind of used to it with Go projects. You can see he's been working on the daemon. We've got more vendor crap. Let's just try and filter out some of these top ones because I think they're skewing our look at what's happening. Whoa, okay. What we got here? So that's daemon, vendor, dot, Integrations CLI. I mean, the vendor stuff just makes it really difficult to see where effort is, and actually it's probably going to skew most of the stats. It's disappointing. So we can see some commits to the API, the HTTP util, the API, Docker file, the client. So we can still see where the effort is going, even though it's a little bit more difficult in this project. And I can keep trying to zoom in to pull out more stuff, but the daemon, container, builder, hack. So we can see where some of the effort is, but I think that vendor folder is kind of causing a bit of a haze over what's happening. Okay, what else do we have here? We can just see the Go. I don't know what the .none is. We've got comp. So I mean, as a Go project, this is what I would expect. All right, something else we tried to do with Git series is provide more helper things. Now we already kind of seen the file extension 1 on the overview dashboard. Something else we try to do is using conventional commits is try to pull out as many of those components as possible. So if you want to, let's say, get help with the daemon, then I say, okay, package control the daemon. If I want to go speak to someone, I want to understand how to make changes to this daemon, I now know who to go and speak to. You know, these are the people that are committed to this directory. I wonder if that's Kubernetes. I don't think this is reloaded properly. Yeah, if I type stateful set, or maybe this query is wrong. Let's check. It should be okay. It's just, I think everything's just fallen to pieces with this import. On the plus side, the buffer fullness is dropping. Should be back in business then soon. So let's try something that's definitely only going to be in Docker. Let's think. Swarm. Okay, so we can see a swarm router. Marant is popping up. I guess that's not a surprise. And we see some people here. So, I mean, the TLDR here is these tables are a really, really good way. Not just, our IDEs do support some level of introspection here where we can see who modified that line last or who was the last commit in this file. We can do a git log on an individual file and get names, but I think this is just so much more valuable in the fact that we can filter on any directory and we can see the commit counts as well. We know who the prominent committers are versus the people that probably come in and fix a typo. So this is a really good way to navigate your code, especially joining new companies or looking at new open source projects and trying to work out, right, how can I get help for something I want to do here. We also have the concept of code owners when we do the Git series analysis. I've seen .derek.yaml here. It's no surprise that Alex Elsie's name is next to that. So you can see he is the founder and I think maintainer of the Derek bot project. We can also maybe just filter on, say, something specific within Docker. Let's try it. It must be a C group file of some kind. So say I want to understand vendor directory is going to ruin everything. Let's just pick a random file. Maybe I want to improve the testing around the integration containers and the C group namespace stuff. I'm assuming just say words that's in that file name and that'll make sense, right? And what we can see, there's a few people here I could go reach out to. So the concept of a code owner would just be who is the most prominent committer to this file. Something else that Git series will try and do for you is just give you a table of every commit within the window. So, I am looking at 18 months right now, but we can just scroll through all these commits. If I click on one, I see the author, when it happened, and I can just copy that git SHA. So if semantic commits were a thing, I'd be able to break these commits down by the component or features or fix and just see all the features that were released in the last 30 days, all the fixes that were released in the last 30 days, all the refactoring and so forth. So a nice way to take a look at project. Really painful over large windows. In fact, if I ran this across the 7.5 years, it'd probably drag a little bit, but I am running beta version of this software, so we have to give it a little affordances. Something else we try and graph is just looking at files that are new within the project. So this is really good as a way to understand any migration paths within the project. Like if something I seen when I analyzed the InfluxDB repositories was that I could actually visualize through the graphing the transition from JavaScript to TypeScript. Analyzing the Moby project, I'm not going to see anything like that because it's just all Go mostly. And then other ways to visualize that are just a scatter plot. What directories are changing, what type of file extensions are changing. We can also see deletions over time. So, when you write enough Go, you're going to be deleting enough Go. You can see PB files being deleted here. I'm not sure what those are. Some JSON files being deleted. And that .none, which has been a regular popper-upper here. I'm not sure what that is. Something else I use to kind of understand how healthy a project is always by its documentation. So what I can't give you is the magic number that you should have, 1 line of documentation for every 10 lines of real code. But you'll have a good understanding of the projects you're contributing to or maintaining, of whether you have enough documentation. And if not, you want to be getting this purple line moving closer to the blue. So the blue is just how many lines of code were inserted within this window. Like if we use this as an example, there's 5.3 thousand lines of code that were not comment markers versus the 1,200 lines of code that did have a comment marker, which is a pretty good ratio. 5 to 1. I would definitely take that. Some of the open source projects I have analyzed, it's been closer to 20. One line of comment for every 20 lines of code, and that's always been slightly concerning. And if we want to just break down those comments by the file extensions, we can see that the majority of all of the comments are in Go code and very little in anything else. Now there is a bit of a bug in Git series, and that markdown files always show as comments because they have headers in them. So yeah, it does the best it can. Did I skip anything else when I was running through this dashboard? No. So it's disappointing. There's no conventional commits. We did get a look at the directories over some window. Still flushing. But it would have been nice to see a bit more there. So projects that adopt conventional commits are going to get a lot more value by taking a look at this. Now the year-on-year analysis repository, dashboard even, gives us a way to just kind of look at the lifetime of the project, comparing year after year. I don't think I've really got this dashboard great yet, disclaimer, but you can try and pick up a few patterns. So we don't want to look at Kubernetes, and what I'm going to do is just do quarters, and we'll do Moby. Give this a second. So even though the time period here is 1 year, the January 1st, 2019 to January 1st, 2020, it's actually pulling out all data. I think it does like a 20-year scan, but then aligns the time windows so that we actually see each year here starts here and ends here, and we can see where the peaks are. So we can see that as far as releases go, 2015 was a huge year for Docker, or the Moby project. And then we can kind of see there is obviously some of it, a little bit of a release cadence here between the two purples. So what's that? 2017 and 2018, pretty strong cadence. Lines are together. And then a little bit variable through other years. With regards to commit counts, we can see their best year probably was, that's 2015. 2015 or 2018, with 2019 being pretty much the lowest year in terms of commits ever. So slightly concerning. I don't think Docker's in particularly great shape with those, just looking at those graphs. And we've seen that earlier too. Now, these dashboards can be kind of useful if you know the people and you want to understand just who's contributing what to your project. But what we can see here is that the most substantial year, gauging it by the number of commits, which is of course no way to measure productivity of a developer, but we can see that 2013 Juliam has a substantial amount of commits. It's the highest over any other year per single contributor. Michael Crosby in 2014 to 2015. What have we got? We've got Solomon in 2013, and taken over for 2019 into 2020. We've got Sebastian. So you can just kind of highlight who the driving force behind the project is. And again, if we had the conventional commits, these two would be fantastic too, and that we'd be able to understand, how does 2019 compare to 2017 and 2016 or 2018 with regards to how much features we delivered versus how many bugs we fixed. So because we don't have that data with the Docker project, these graphs don't drive a lot of particular use. And this wall of shame, I really need to rename that. It's such a dreadful name. It's basically just a random one where I had like an idea of things I would try and do like leaderboard style stuff. The challenge with the leaderboard stuff is the queries are super slow. So let's check if Telegraph is finished first. So we've got 1 million to go. Okay. Let's take a look at the last year first. Shouldn't be too painful. And then maybe we'll try and widen that as the Kubernetes stuff finishes. So what this does is it tries to calculate the robot. So this doesn't do a selector on repository, but we should add that, shouldn't we? So let's modify this query, and we're going to say where repository. I know, computer, I'm beating you pretty hard. We'll just copy this because we're going to add this to all the dashboards here. And go. I didn't submit that first, but I'm hoping the query should be okay. We're going to take this off Kubernetes. And we're going to modify these ones here. So just making sure that they're all using the repository filter. The reason the repository filter wasn't on this is I was running it against all of InfluxDB's repositories, and it was actually kind of useful to have a global view. But just because I'm doing a couple of open source ones here, really doesn't make a lot of sense. Okay, so this first one just kind of works out the highest number of commits per person per month, and then shows us the months, orders them by the month of commits. So you can see, we already saw from previous graphs that Sebastian from the last 18 months has really been the driving force behind the Moby project. Again, don't use commits as in a productivity, but in March 2019, he hammered out 375 commits. That's more than 10 commits to master a day. I mean, that's substantial. Oh, come on, computer. Not long to go. I'll give you a break. I mean, these queries are particularly rough, especially the needs a holiday in the mean days coding one, because they are doing aggregates across days. The mean days coding analyzes groups all the commits by day per author, and then tries to give you an arbitrary number, like, if you were to work on this project, how many days per month would you spend contributing code to the master branch? So it's usually, the higher that number generally shows the maturity of the project, because pull requests are being handled relatively quickly. The CI/CD means that those changes have got a level of confidence. There's good testing. It just means that that cycle time from creating a branch, pushing your first line of code to hitting the master branch is really, really important. Maybe more so, and private organizations with private repositories than an open source. Open source can have a certain of affordance of moving a little bit slower. let's see what's going on with Telegraph here. Because we still want to be able to run, at least get a quick look at Kubernetes before we finish up. I just realized, I wonder if the load my machine is under has maybe caused any problems with the stream. Although I don't think I've had any comments to suggest that, but. Oh. Computer. I mean, I can't even get focus on my terminal. Okay, so at least you can hear me, but what we have now is my computer seems to have completely locked up. I cannot focus on my terminal to kill Telegraph. Visual Studio Code is trying to display an error message and failing miserably. Yeah, it's just locked up pretty bad. So I don't know whether to... Damn. Now my browser is unresponsive. Telegraph. Oh, I've got focus. Can I kill it? Oh, I've lost my mouse. Right, I have typed kill all Telegraph. Let's see if I can. Oh, I spelled Telegraph wrong. Kill all. Let's see if I can just get it killed. it's getting a bit more responsive. Is it dead? Oh, don't kill PID 1. Kill that PID. Right, good. Wow. Oofed. Alright, so what happens? I don't have HTOP, so I have top. It's load spiked to 35 on my 8-core machine. Nice. RAM usage on influx is sitting at 50%, but I'm responsive. Code definitely crashed. We can open that again. And I'll just hopefully type that I'm back. Okay. Let's just make sure. Right, well, influx is still running. Silver lining here. And let's reload this dashboard. That's a bit better. So this table here tries to kind of tell you how many days of the month you'll be pushing code to the master branch. Now, for an open source project, you know, being around 8 days, it's pretty good. I'm analyzing Moby here. This could also just be an indicator. I mean, there's maybe much more of a commitment by the company rather than open source contributions. Just because these numbers are higher than I would expect for an open source project, which means that probably a substantial amount of the committers are employed by Docker rather than open source. But that's obviously a little bit of speculation at the moment. Okay, so before we finish, let's come back into the overview. In fact, no, let's just go straight into the single repo. Let's see how much of Kubernetes we got. And I think what I'll do is I'll do my own session with Kubernetes with a chunky VM just to ensure we have no issues. But I still want to see if we can take a look at it just now. Okay, so I can see that we processed 55,000 commits. Of 92,000. Now, that doesn't tell me how much of the deltas we processed. Maybe we'll get a little bit of an indication of that as we go through this dashboard. So let's just do that and see what happens. So we can kind of see the inception of Kubernetes seems to be around the 2015 mark. I think that's right. I don't think we're missing too much of the commits from here. It may just be later commits. So I think what I like about this graph here from the Kubernetes perspective, okay, so we've got deletions in a kind of red color, insertions in purple now, rather than the blue from earlier, is that we do see a lot of features being driven. You know, the insertions higher for the entire, first year and a half. In fact, insertions are just consistently higher, aren't they? There's just always writing new code, a little bit of deletions here. But there are still a strong sense of changes and deletions throughout. Let's see what we can work out down here. In regards to what our average commit looks like in this repository, 2 files, 15 insertions, slightly larger case up to 300. So, you know, again, just a sign that commits are generally focused. They're not too large. You know, there are some projects you analyze where, you know, the mean commit can be, you know, 300 lines or 1,000 lines of code. So just shows that obviously they've had a strong sense of how to build this product out from the start. We see a pretty good release cadence moving forward. I mean, there are some spikes, but you know, those could be patch releases. We see betas here and the versioning and stuff. So let's just see if we can get some more interesting stuff. I wonder how much of the offer information we have available to us. I've not got much hope for the semantic commits. This big blue line again. Okay, so we've got the Kubernetes merge robot, and we've got the submit queue, CI robot, and prow robot. So, you know, normally if I wanted, in fact, when I do a deeper analysis of this repository in its own session with a nice big shiny machine, you know, we'll filter this stuff out. What we actually want to be able to see is just, let's just drag this as the people behind this project. So let's see who have we got. We've got Brendan Burns, also one of the founders of the project, not committing so much anymore. Got Brian Grant. What about, that's just robots. We've got Adam with a spike here. Dr. Stefan. Yeah, I mean, I think anyone who's familiar with the Kubernetes project knows Jordan's name. You can see, you know, being committed to this project substantially from start to finish. And then we can obviously, you know, if we wanted to zoom in again, we can try and get into these little lines down here. But, you know, you can definitely identify some of the key people in the project, as well as the if I just double click and reset this, you know, we can see the project has always had a really strong sense of automation. We can actually see the death of the Kubernetes merge bot when it got replaced by the Kubernetes submit queue. We've got a CI bot popping up here, very short-lived experiment, and then prow active in the project for the last 18 months. So we can actually see the evolution of the automation on this project. I'm not familiar with the Kubernetes merge robot. But we can see that, you know, it's definitely not in use anymore. The submit queue I'm actually not even familiar with either. I think when I do my deeper dive on this repo, we'll try and get someone, one of the earlier committers of Frequency, maybe Jordan will join us, and we can just give us a bit of history and background on what these automation projects were. The CI robot, definitely a short-lived experiment, and then prow is what's being used today. So. With regards to the semantic commits, we've got a whole load of nones. I'm not holding up much hope for Zoom, but let's just... No. It's all too close together. Let's try here. What we got? Kubernetes component, useful. GitHub component, useful. Nope. Yeah, we're not going to get any information from the commit patterns. But we do have the directory breakdown, so let's see what we see there. Okay, that's just noise. The Kubernetes project, as far as extensions go, it's pretty much just going to be exclusively Go again. There's not going to be really anything exciting or interesting here. Let's just give this a moment. Okay. Any Rust? No, but we have restructured text. Wow. Not a lot though. What else? What else could we look for? Any Perl in this project? We do have Perl. Jordan. Okay. PHP. Oh wow, we have a PHP commit. Maybe a little bit of PHP in here. I'm not sure what that is. We could always dig into it and find it if we were genuinely curious. Do we have a DS store? We do not. Drats. I don't know why I enjoy finding a DS store. It just keeps me happy. Computer's locked up again. We will make it through this dashboard. We will. Okay, we're back. So components, because this component is a directory breakdown rather than a semantic commit, we should be able to understand some of the aspects here. In fact, I may, just because my computer is struggling again, drop the time period down when my computer lets me do that, obviously. And what we'll do is we'll maybe just try and take a 12-month look at Kubernetes and see what's actively being worked on just now, or maybe even the last 3 months. You know, we can just get a feel for what's happened or what's changed in the last few releases. So let's do 2019 06 01. Let's just take a look at 12 months. It should be 3 or 4 releases depending on how we hit them. And you know what, I'm just going to do a hard refresh on this. So in the last 12 months, we've had 7,000 commits, 500 per month. Definitely a lot of features added at the end of last year. And the releases since then have mostly been changes and bug fixes, I would speculate, based on this graph. Now, I actually know, because I was the comms lead on the 117 release, that this release here was actually just a triage bug fixy, make things better release. So the chillest release, I believe the title was. All right, so let's come back down here. Right, hopefully that should be a lot faster now. Surprised that it loaded the commits a lot faster than these two, but okay. So component wise, let's just maybe scroll and see what we have. There shouldn't be. We got that vendor directory. See, Go projects are always the worst to analyze. Let's try to do stateful set. So, you know, there's a stateful set controller. We can see, you know, the commits over the last year. There's not been a lot of activity there. But we do know who to go speak to if we wanted help. Coders, so we don't need to look at that again. It was pretty much the same. I'm more interested in the directory breakdown. That's going to give me the overview. Those tables are really good for when I have specific questions. If you don't know the question yet, then the directory breakdown and these graphs are actually a bit more interesting. So we can just see, it's all Go code. We've got nones, no extensions. PB, protobus, yep, not surprised to see that. We've got some shell scripts going on. With regards to directories, we can see staging test data here. We've got test data. You know, we didn't see a lot of insertions. So, you know, the fact that what we're seeing is test stuff just shows how much testing goes on in this project. And it could just be, if we zoom in, we can hopefully get a slightly better look. So we can see some framework plugins on the scheduler. We can see RPMs were there, changelog, and then we've got some of the components. We've got the Open API spec. So we can see what's been worked on, but it's very difficult on a project of this size. I think what I'll need to do when we do an even deeper dive into the Kubernetes project is just provide a means for filtering out the vendor directory for sure. I think that's definitely going to increase our visibility into this. New code, I mean, not surprised to see Go there. It's a Go project. So, and we can see the comments if we want to wait for that. We can see which files have been deleted by directory and so forth. So I think I've put my computer through enough. Yeah, let's call it quits there. Well, I can still I think I'm still going. Yeah, okay, cool.